So let's get started. First, I want to thank Jim and Monica and the team at Erlang Solutions for organizing the event. And I also want to thank everyone for coming. I hope you have 2 great days of conference with a lot of learning. And this is going to be the usual talk. So the plan for today is going to give a little bit overview of what happened in the last 1 year, 6 months since the last event. And then we're going to talk about the usual stuff, what is happening in Elixir Master and what we can expect in the upcoming Elixir releases. And then we'll go to talk about more of the long-term things, right? Like what are things that are bothering us and bothering the community that we want to solve in the long term and what we are doing to solve those things. So let's get started. So Elixir 1.0 came in September 2014. Who started before Elixir 1.0? All right. So, and then who joined in the 1.0 branch around? Cool. Yeah, we'll continue the showing of hands soon. So Elixir 1.0 came in September 2014. It has not even been 2 years, but it feels definitely like much more than that. It was great because we had more than 180 contributors, code contributors, to the language. We had 3 books almost out. They were actually just waiting on the language to be 1.0, so the books could also be final. And we just had our first Elixir conference in Austin, Texas. And for those who were there before Elixir 1.0, it was a period with quite, because it was before the first official release, we had the opportunity to still do backwards incompatible changes and things of sorts. So we had a lot of churn, right? We were removing features, adding features. So what we decided is that after Elixir 1.0 was out, we said, okay, we're going to wait a little bit now. We have this foundation, right? And let's build on top of that. Let's let the ecosystem start to build itself. And that's why we waited a little bit. We waited a year, so we got Elixir 1.1 out. So who joined with Elixir 1.1? A little bit later. Cool. And so that was September last year, and we had almost 300 contributors. Hex was also reaching some important milestones, like we just reached 1,000 packages. And we had both the first Elixir conference in the United States and the Elixir conference Europe. And at the beginning of this year, we released Elixir 1.2. So it was like 1st or 2nd January. And the reason we released quite early on, at the beginning of the year, is because I don't have to do any more work for the rest of the year, right? We got our release for 2016, done. Now it's just smooth sailing. Okay, so, and then we can see more and more code contributors coming to the language. And since this release, at the beginning of this year, a lot of interesting things happened. So we started to see, first, more local events. So there was Elixir Days in Florida. There's going to be the Empire City Elixir Conference in New York in 10 days or something. Our learning resource page on the website, it continues to grow. We have more books, more screencasts, and other resources so we can learn Elixir in a bunch of different ways, more books. One of those initiatives I really like is Elixir School. So the goal is to teach Elixir in a wide range of different languages. There's also the Elixir Forum, which is something we are trying right now because today a lot of the discussions in learning and improving the language is happening over the mailing list, and that's not a proper medium for us anymore. So we are starting with the Elixir Forum, and we're going to see how that will work. We're starting to transition the mailing lists there, and you can see that it's definitely a better place for having discussions. And Hex got a new page, and I really like it because now we're putting, so Rebar 3 is the package manager for Erlang, and they adopted Hex as well, which is going to help us have more and better packages. And they got this new page, and I want to, where is Eric? Eric? Okay, he woke up. So I actually want everyone to clap and appreciate the work. that Eric and the Hex team is doing with everything, both in terms of security, infrastructure, server side, client side, integrating with Elixir, integrating with Erlang. There's definitely a lot happening there, and Eric's leading this work, so really great job. And there are a couple packages that deserve kind of a special mention. So one is Phoenix. So Phoenix got the 1.0 release and then even more releases later. And it's interesting because in the early days, right, when Elixir was a language in development, a lot of the community came, and the main goal was to learn the language itself, and that was some experience. And now with Phoenix out there, and as we're going to talk next, Nerves, it brings a different perspective because a lot of folks come like, hey, you know, I want to build this thing. And of course, you need to learn the language to build this thing, but it's more of a side goal, and that changes the dynamics. And it's a really interesting experience altogether. So Phoenix got to 1.0. We also have the Nerves project, which it's trying to spread more knowledge about embedded and get more developers interested in embedded development. And they are doing great work, progressing really, really fast, and that's also interesting. And we are going to have keynotes by Chris and Justin, one for Phoenix and one for Nerves tomorrow. So that's definitely going to be interesting, really looking forward to that. And besides the projects, we started to see more and more companies using Elixir in production. I'm going to show 2 cases that I find interesting. So for example, Moss, they wrote this very excellent blog post where they are rewriting part of the infrastructure, and they just ditch the database, right? And they say, wait, we have Elixir. Like, those things are really good to be running for a long time. So what if we just ditch the database and do all the work we need to do by keeping the data in memory? So it's really interesting blog post. We also have companies like Pinterest deciding, hey, we're going to start investing in the Elixir community in the ecosystem. And those, of course, they're just 2 examples. For example, Chris tomorrow is probably going to talk about companies that are using directly Phoenix in production, and Justin is going to talk about companies building hardware and software with Nerves and shipping that and selling that. So I wanted to focus on those 2 because they're more Elixir-centric, and to me, they're really, really interesting. Cool, so that's, as the name said, it's just an overview. It's not meant to be a completely, a full detail of what has happened, but some of the highlights. And now let's talk a little bit more about code. Let's talk about what is coming in the Elixir 1.3 release. So one of the features that actually makes me want to release Elixir 1.3 today, because I think this is going to be a huge, it's going to be really important for the community, is the addition of calendar types. So here is some code, okay, and we see examples, many examples of this kind of code, and that's what triggered us to add calendar types. Imagine that you want to get like yesterday, add 1 hour to it, and persist it to a database using Acto. So we're going to say, look, well, we have this library which is really well named called good times that is going to, you can get yesterday, and it has a lot of functions that allows you to get yesterday, today, tomorrow, and things like that. But what good times returns is the very old tuple format that Erlang has. So you need, if you want to use it with the datetime library that allows you to do all kinds of manipulations, you need to call like from Erlang, and then you can add hours, and then you need to convert it back to this tuple format so Acto can read it and persist to the database. So that's not good, right? Like, the real logic is 2 lines, and then the rest is just boilerplate getting in the way. So what we decided to do is that Elixir 1.3 is going to ship with 4 new data structures. Time, which is hour, minute, seconds, microseconds, date, which is year, month, a day. And then we have naive datetime and datetime. And this is really interesting because, so naive datetime is the date and the time without the time zone information. And the reason why it's naive, it's because if you don't have the time zone information, that date may not actually exist, or it may be ambiguous. So for example, when we have daylight saving time, right? We need to move our clock forward 1 hour, or move it back 1 hour. When we move it forward, there is a whole hour that's gone, disappeared, right? So if you don't have the time zone information, you cannot actually validate that. So that's why it's naive, or it can happen twice when you move back the clock and you need to know which one you're actually referring to. So that's the naive datetime, and then the datetime, it actually has the time zone information. And the goal with the calendar types is, as I said, is to provide a common ground for interoperability. And that's why I'm really excited, because when we release Elixir 1.3 and the libraries start to adapt those new data types, right? We are going to, it's just going to be easy to have a library that is doing parsing, another library that is doing formatting, and it's going to allow the ecosystem to grow and integrate better, okay? Have more specific responsibilities. And for now, the goal is to mostly focus on the types. However, we do want to add just some very basic conversion functions, right? Like convert from Erlang into Erlang and things like that, and maybe get an integer which represents the Unix epoch and things similar. And we also want, one of the design goals of the library is to support multiple calendars. So the one Elixir is going to support by default is the calendar that we all use, okay, which is specified by the ISO 8601 format. But if libraries want to bring other calendars, it's going to work with that as well. And I have to thank both Lau and Paul, that Lau works in the calendar library, Paul works on Timex, for opening up the discussion so we could add those types. So basically, when I saw code like this, right, I was like, no, this is not good. And then I sent an email to Lau and Paul, and today is a thread with like 60 emails where we had all this discussion, what should be those types, and it was a very enlightening discussion. So I want to thank them. So cool, so this is one of the features that I'm really excited about. There is some other feature that I'm also excited about, but there are more people excited about it than me, which is with. So Elixir 1.2 introduced this new special form called with, okay? And I really love it, because here's some code that I actually wrote. I'm working on this thing called a DynamicSupervisor, which is a supervisor. One of the things that the DynamicSupervisor receives as arguments are data like the strategy, the number of restarts the supervisor can do in the given time period, which is max seconds. And when we receive this data, we want to validate it. So what this code is doing this. So I want to validate a strategy. And if the value that validates strategy returns matches OK, I'm going to validate the restart. And if that matches OK, I'm going to validate the number of seconds. And if that matches OK, I'm going to return OK with the state. So it's very succinct and readable, right? And the way those small functions, validate strategy, validate restarts, are implemented is just this. So I want to validate the restart, and the restart should be an integer. And if it's an integer, I return OK, so that's going to match. But if that doesn't return an integer, I'm going to return a narrow tuple, okay, with the reason why that thing is not valid. So basically, if you look at this code, it can return, this chunk of code can return two things. It can return OK and state tuple, or the error and the message, because if it doesn't match, it's just going to return the value that does not match. So really, really handy. But there was an issue. As soon as developers started using this feature, they realized that sometimes they actually want to change a little bit this result. For example, they want to add some more information to the error message, or let's say they want to upcase the error message for some reason. And with Elixir 1.2, which is the version it's out today, the only way to do that is to get the whole chunk, assign the value to a variable, and then here at the bottom, you're going to pattern match on the variable, and then if it's OK state that you return here, you want to keep it the same, but if it's the error message, you do the operation you wanted to do. So Elixir 1.3 is introducing this feature called with else, which is the opportunity to add else to the with. And it's going to be invoked in case one of those clauses do not match. So if by any chance any of them returns the error tuple, we are going to match on it, and then we can upcase. And the reason this is really interesting is because when we added with to Elixir 1.2, we actually discussed about adding else. And then we said, you know what, this feature is really, really new, and we don't know if else is going to make sense in the long term. So let's release with as is, without else. And we'll see how the community will react and if adding else in the future makes sense. And as soon as we release Elixir 1.2 and developers starting using with, a lot of developers from different places, from IRC, mailing list, sending us emails saying, you know what would be really cool is that if we could use else because I really need this pattern in my code. So it was really interesting because everyone came to the same conclusion, like, no, that would be really handy. So there it is. It's going to be there in the next release. XUnit, which is our test framework. I'm sorry, you may not be able to see this quite well. But XUnit is our test framework. It's also getting improvements. And one of my favorite improvements is that, for example, when you compare a left value to a right value, so here I'm comparing two maps, we print the left-hand side. So imagine that you have a large map, here a map, for example, with 30 keys, and you want to compare it to another map that has approximately 30 keys. If your assertion fails, you're going to print those two large maps, right? And then you need to go, oh, 11 is here, 11 is here, 39 is here, right? That's not really nice. So XUnit in 1.3, it's going to do a diff between data structures. So if you're comparing strings, it's going to say, look, that's the part of the string that is different. I really like what we are doing for maps. So if you are comparing two maps, what we do is that we show, look, the key 23, it's the same, exists in both maps, but the value is different. However, the keys 8, 7, 6 were removed, and the key 33 was added. So this is really good because with a very quick glance at the diff, you know exactly what are the differences, right? And you can act on it. So I'm always using Elixir Master, and you know this feature has been a really lifesaver, and Alexei is working on it, and we are continuing to ship improvements. So that's a great feature coming in the new release. Mix, which is our build tool, is also getting improvements. And one of those improvements, I actually talked about it last year, that we wanted to do it. And it's the addition of Escripts for Mix. So Mix has this feature called archives. So this is since Elixir 1.0, it's there for a while. We have this feature called archive. And if you use it Hex or if you use it Phoenix, you use it archives. So when you want to install Phoenix, for example, to generate your first application, you do something like mix archive install and the path to something. And what that's going to do is that it's going to get that tar file, put it in your machine, so you can run a command like this, mix phoenix.new, new app, and that's going to generate a new application. Mix Escripts is a little bit similar, so what we're going to do is that you can do mix Escript install, and you're going to give a path, but instead of installing an archive, it's going to install an executable, which then you'll be able to execute like Phoenix new app, right? You no longer need the mix, it's just Phoenix new app, right? It's a standalone executable. So why are we introducing scripts if they're both quite similar? They were added exactly as an alternative to archives because archives, they only run inside mix. You need mix there in order to run the archive, and that's why we tell people to not go crazy with archives because every time you run a mix command, mix is going to load the archives. So if you have like 20 archives, you're going to make every command that you run with mix slower, right? And you don't want that. Mix is a essential tooling in the ecosystem, okay, in our everyday work, okay? So we don't want to do that. And Escripts give exactly that. They run completely apart from mix, and they do not even depend on the Elixir version that is installed locally. They have a copy of Elixir inside of them. So they are much more isolated, and that's really, really good. That's exactly what we wanted. Another good change that is coming to Mix is we now have an environment variable called mix_debug, and we are continuing to improve it. So if you're ever writing a mix task and you're a little bit lost how things are happening, if you run now with mix_debug1, it's going to print everything that is happening, right? Like, look, I'm running this task for this project, and if there's an error, it gives all the information that you want for the error. So it's a very small addition, but it's really, really helpful when you're working with Mix. We also have 2 new very useful tasks, which mix app.tree and mix daps.tree. So app is going to print the tree that you specify in your application file, what are your application dependencies, and those are the dependencies like hex packages, GitHub repositories, and things like that. So here's an example. You can also try Elixir Master and see it for yourself, but here's an example that you get from running it inside the new Phoenix application. You get like the name of your application, and then you say, look, it depends on git tags, that is a hex dependency. It depends on Phoenix PubSub, that is a GitHub repository, and you have a good overview of your project. And right now, we are printing it to the terminal, but if someone would like to contribute something like -- dot that would actually print a dot file with the tree using images, that's going to be really, really sweet. Cool, so that's just a very small overview of what is coming in Elixir 1.3. Daniel Perez, he wrote this article calling What is Coming in Elixir 1.3 that go over a lot of other changes that are happening in the language and with more detail that I have given right now. So I recommend everyone really to check that for more information of what is coming next. Cool, so, those are some of the changes, some of the things I'm personally excited about, and I hope you're excited about for the upcoming Elixir releases. And this is the part of the talk where we want to talk a little bit more about long term, okay? So one of the things that we have been always thinking is like how we can improve OTP, right? So, and by OTP, I'm mentioning all those building blocks that we use for building distributed fault-tolerant applications. So when we use a supervisor, when we use agent server, right? Those are all those building blocks coming from OTP. And there are two things that I have been planning to improve them for quite some time. It's the simple one for unsupervisors and the GenEvent. And here I need to do a disclaimer. I think it was last year that I talked like, look, we want to improve GenEvent. And somehow it became like, nobody should use GenEvent ever. No. It's like, if you have a problem, for example, where you want to send events to an entity and you want to broadcast those events, GenEvent is a good solution that we have today. And if that fits your problem, you should definitely use it. That doesn't change the fact, however, that it could be better. Okay? And that's why we want to focus here. So let's talk a little bit about those two. Okay? And then we are going to talk what we are trying to do to solve this. So when you use the supervisor, right, so you create your Phoenix application or create a new application using Mix, in your application file, it defines a supervision tree and you choose a strategy, right? And we have 4 strategies. We have one for one, one for all, rest for all, and simple one for one. And one of those do not look like the others, okay? So the first 3 strategies, they are quite similar in terms of API and how they behave, but the simple one for one is a little bit different. And in order to first understand why it's a little bit different, we need to understand why we would use the simple one for one. And we use it every time we want to spawn children dynamically. So for example, when you are building your web application and then there comes a request and we start a process to handle that request, right? Requests can come anytime, and we are starting those processes dynamically. So internally, our web server, like Callboy, it uses something like a simple one-for-one supervisor. So that's the use case. It's just, or for example, if you wanted to, you have those requests coming and you want to send emails, and to send those emails, you are starting new processes. You want to put those on the simple one-for-one supervisor because it was built exactly for spawning children dynamically. Right, so every time you want to start a supervisor process dynamically because something else triggered it, you use a simple one-for-one supervisor. And that's important because the design of the simple one supervisor, the implementation, was done in a way where we can actually spawn hundreds of thousands of children, millions of children. And the representation needs to be lightweight and things like that. So that's the use case. In order to support this use case, a couple things are different. So for example, in a regular supervisor, when we pass the children that we want to start when the supervisor starts, the supervisor is going to get that list of children, right? So say, I have child 1, 2, and 3, and it's going to start that in order. However, for the simple one-for-one supervisor, every time we specify init, it must return just one list with a single child. Cannot have 0, cannot have 5, needs to be 1. And that child is not started automatically. It works as a template. So it starts to get a little bit confusing, right? Because you have the supervisor module, and then you have 3 strategies that start things on init, and then you have this special strategy that behaves a little bit different. Not only that, so here's something you can do. Go to the supervisor documentation in your terminal or in your browser. Just do hsupervisor in IX. And you're going to see that a lot of the functions in there, they have if the supervisor strategy is simple one-for-one. The input is this and the output is that. If it's one of the other strategies, the input should be this and the output should be that. And that's not good, right? I never remember what are the proper APIs we can use in the simple one-for-one supervisor. And when we are explaining it to someone, it's always a little bit maddening as well. So we definitely want to improve that. And there are a bunch of other cases where the simple one-for-one supervisor is different or just slightly different enough to be maddening. Okay, so what we want to do then to solve those problems that, if that thing doesn't feel like it belongs there, let's just break it apart. So instead of having a supervisor module, what if we have something called a dynamic supervisor? And all it does, for now, is to implement the simple one-for-one strategy, except we no longer need to call it simple one-for-one. We can just call it one-for-one, okay? And we've actually done this work. That code I showed at the beginning with Riff came from this implementation. And for now, that's all it does. It really got that code from the supervisor, and we put it apart elsewhere. But now that we did this, now we broke it apart, we started to ask questions like, what else could be useful for our dynamic supervisor to do? Because now it's much clearer. We have this particular code, very concise, with this specific responsibility. So how can we improve it? How can we make it more interesting? So for example, what if we have better back pressure mechanism? Because if you have a supervisor and then, for example, you want to send emails, right? Starting children the supervisor to send email. Today we have no back pressure. You're going to send, you have a lot of processes pushing messages to that supervisor, and they're going to wait how long it waits for the supervisor to start the child, okay? And so there is no back pressure. So what if we could say, look, I can only really send 1,000 emails at the same time. So we can specify this limit, and then if you reach this limit, if you try to start a child, if you try to send a new email, it's going to say, look, it's overloaded, I am full. Okay, so this is a better way to do back pressure for push commands. But what if, so in this case, as I said, we are only pushing events to the supervisor, but what if the supervisor could actually pull? What if the supervisor could say, look, I can send 1,000 emails, and when everything starts, it tells someone, look, I can send 1,000 emails now. And then you start sending those emails, and then maybe you get 1,000 to send it the first time, and then now the supervisor, look, of those 1,000, I already sent 100, so you can give me more 100 to send. So it's more of a conversation, right? It's not like pushing and then say enough. It's like, look, I can send 1,000 now I can send 100, now I can send 200, and then you have better back pressure because the two layers are communicating with each other how much data you can actually work with. Okay? So those are things we'd like to explore, right? Dynamic supervisor and better back pressure mechanisms. Cool. Now let's forget the supervisor for now. Let's talk about GenEvent, okay? So what is GenEvent? So GenEvent is one of the abstractions like GenServer, Task, Agent, Supervisor, and it is used for handling events. And when you start a GenEvent, you will start something called the GenEvent Manager. So every time you send an event to the manager is going to broadcast this event to different handlers. But the thing about GenEvent is that when you add a handler to handle those events, those handlers, they are not new processes. They are a piece of code that gets attached to the manager. So as you go and you install handlers, you're installing all this piece of code through the same process, to the same manager process. So have all those entities here kind of running the same process. And the issue with that, so we have the GenEvent, and then we have a manager that broadcasts events to handlers, but really it's a pseudo broadcast, right? Because those handlers that we saw here, they are not separate processes. Everything is in one process, which means it doesn't exploit concurrency. Everything is running in a single Elixir process, which means it's not going to leverage all cores. Okay, if you wanted to exploit concurrency, you need to write that yourself. That's not good, right? We can definitely do better than this. And it has really awkward error semantics. So because the handlers are installed into the manager, if there's a bug in the handler, the manager is just going to throw that code out. Say like, I don't like you anymore, right? It's not going to run this code anymore. So if you want to actually add the code back, you need to create a separate process that is going to see if the handler is still there, and if the handler is no longer there, you kind of add it back. So there's a bunch of interaction. And we know that if the handlers, they are actually separate processes, we could just put it under a supervision tree. And then if the handler crashes, the supervisor would go and start a new one. So, this idea here that we have that all the handlers, they are in the same process, it's really limiting. It's not, in a way, it discards a lot of what we learn about Elixir, right? We want to isolate our code in different processes so we can get fault tolerance and we can get concurrency. We're not doing any of this, okay? And I think we can do better as well. So in my mind, we are going to have a gen something, okay, where the handlers, they're actually different processes. And it's going to support multiple strategies, because why only broadcast? What if I want to send events to all those different handlers using a different technique or a different mechanism, okay? So I want to support multiple strategies, and I also want to provide back pressure. Exactly the same idea we were talking before. If I have processes sending data to the other processes, I want to make sure that we're never going to send more data than we are supposed to. Okay? I want to have that conversation going, like, hey, give me 10, now give me 100. Okay? So that's it, right? Those are the two things we would really like to improve, and we are working on that. And we have been working on that. If you have seen previous keynote presentations, we're always talking about something in this area. So we're kind of working on it for almost 2 years as well. And right now, the place where we are in the research and development of solutions to those problems, that we have two new things called GenStage and GenRouter that I would like to talk about. So I remember very clearly in the first Elixir conference in Austin, I had a slide like this. I was talking about collections, okay? And that's one of the ways we can also get to this problem. So let's forget a little bit about the supervisor and the GenEvent, and let's talk about this other problem. Look, so many problems, right? So we have this idea of collections in Elixir, and this is code that works today. So we have something like, say, we have widgets, and we want to keep only the widgets with the color red. And then we want to map over those widgets, getting the title and the height, and then we want to put everything into a map, okay? So the widgets, they are what we call enumerable. It doesn't really matter what those widgets are. It doesn't matter if they are a list, if they are a set, if they are a map. As long as they implement this that is called the enumerable protocol, this code is going to work, okay? And the map here at the end, where we put all of our data, it doesn't really matter what it is. It doesn't need to be a map. As long as it implements the collectible protocol, this code is going to work. So we have this protocol that knows how to get items out of a collection, and we have this other one that knows how to put those items back into a collection. And this allows us to do very interesting stuff. For example, I can get this code, and I can replace the widgets in the map by something like this. I can replace by something that is going to parse the CSV file. So now the widgets are no longer in memory. They are coming from a CSV file. And at the end, instead of putting to a map, I just want to print the data to the standard output. Okay? So that's really nice. But there is an issue with this code, which is, imagine that the CSV file that we are parsing, it is 1 gigabyte of CSV file, okay? Or 10 giga. What this code is going to do is that as soon as we filter the CSV file, we are going to load all the CSV file contents into memory. So if the file has 1 gigabyte and 80% of the widgets in there have the color red, at this point here, at this stage, we're going to have 800 megabytes of data loaded into memory. Because filter is eager, right? It's always going to process everything. And now that we kept those ones, we are going to map over them. So we have like 800 megabytes of data, and now we're going to map to this other list with more 800 megabytes of data, and then we finally get and print everything into the terminal. Okay, so we don't want to do that, right? So Elixir already has this idea of laziness. So if I replace the enum module for eager, right? Enum module is eager. If I replace it by the string module, everything becomes much more interesting. So all I need is to replace the module, and now when I say CSV parse string filter, that's not going to load the CSV file. It's just going to store the computation that we want to do to that CSV file. When we say, hey, I want to map over it, right? It's not going to map effectively. It's just to store, at some point, I want to map over that file. And then we go collecting those instructions. And at the end, when we know everything we want to do, we call stream.run. And what stream.run is going to do is that it's going to fold all this data, it's going to fold all those computations together and perform it in a way where we are going to parse the first line of the CSV file, and then we are going to see if we want to keep it, and then we are going to map it, and then we are going to print it. So the data is now streaming, right? We're not performing those operations in batch. We are doing it one by one, and then we get the next line, and then we see if we want to keep it, and then we map it, and then we print it, and so on, and so on, and so on. Okay, so this is good. It's going to be more expensive in terms of CPU, but it's really going to save our memory, right? We're no longer loading potentially 1 GB of data into memory. And when we had this into Elixir, we started to think, look, if we have this stream thing that encapsulates the computation we want to do to the data, right? We have the data and we have the computation, okay? Maybe we can do interesting things like, what if I get this computation and split it apart? What if I say, I want part of this computation to run into this process using one of my machine cores, and I want this other part of the computation running on another process using other cores of my machine? Okay, so we can get more concurrency and parallelism. So what if, so this is the what if part, right? So what if we had a new function called stream.async in Elixir? And all it does is that before I call stream.async, everything before here is going to run in a process, and everything after is going to run in another process. So now we can see how I'm going to have one process using one core, parsing the CSV file, and as soon as it has some data, it's going to send to the next process that is going to do the rest of the computation, and we have those two running at the same time, right? And that's something that we call pipeline parallelism, because if we call this function stream async multiple times, we are going to have something that looks like this, okay? We're going to have like a process that is reading from the CSV, and then it sends to the next process that's going to do something, and it sends to the next process, until you perform the whole thing. So we talked about this, right, in the past. I think last year we were talking exactly about this at the Elixir conference. And we said, we have a solution. It was a lie. We have a solution to this problem. And it's called GenRouter. It's even in red, because it was a red herring. So we thought, we know how to handle this. We are going to introduce this thing called GenRouter. And the idea with the router is that all those stages, they're going to use this entity called the GenRouter. So I have the CSV that's going to send data to the router, and in this case, the router is going to filter or transform the data somehow. And then the next stage is going to filter or transform the data somehow, and so on and so on. So in this case, we're using the router mostly at transformation, right, to change the data a little bit. But we said, since we are coming up with this abstraction, right, what if we could also use the router to handle cases like this? Instead of being always one-to-one, what if we could have the router receive data from different places and then route it to different places using different strategies? It's kind of, remember we were talking about the GenEvent, and we were thinking that maybe we could solve it somehow, replace it somehow. We were thinking that the GenRouter could do that, okay? But we actually implemented this. We had a prototype running. And then we said, OK, now there are, and as we were running it, we were starting to run into issues. So the biggest issue was that this scenario here, it's actually not good. Imagine that we have a process here, A, that wants to send data to a process here, 1, OK? The way this works is that A would send the data to the router, and that would send the data to that process, which means that the router would quickly become a bottleneck, right? If you have 24 cores, you are passing all the data through the single process, that's not going to work. And that was the problem that we found. We were trying to optimize the router, and it was really, really hard. And the reason why it was hard, it was because, first of all, the router is doing actually 2 jobs, right? I just talked about those 2 jobs, right? We are using the router as a transformation mechanism, and we are using it to distribute events, okay? It was a design decision, but it turned out to be a very bad design decision. It's coupling 2 things, and that's making it really hard to optimize it. And the event balancing, every time you want to route events, right, there is an extra copying because everything is going to go through the router, and the router is going to be a bottleneck. So we said, well, if the issue is that we are coupling 2 things, let's just break them apart. So that's what we are proposing now with GenStage and GenRouter. Like, let's break those responsibilities apart. So now, if we're talking about transformation, okay, we have all those processes that are performing computations, and the GenStage, it only worries about transforming the data. So if you're a developer and you're in the future using Elixir and you're using GenStage, all it's going to worry about is how it's going to transform the data. When the data comes in, do you want to filter, do you want to map, and what do you want to do with it? Okay? And the way the GenStage was designed, remember we were talking about back pressure? It was designed so everything is demand-driven. And what we mean by this is that A is not going to start send data to B, because remember, we want to have that conversation. So what's going to happen here is that every time you want to have data flowing through your system, the first step is that the consumer is going to subscribe to the producer. And that's the first step. So consumer subscribes to the producer. And even after the subscription, the producer does not start sending data. First, the consumer needs to ask for data. Okay? And then after the consumer asks for data, the producer can send data, but it may send data in a way that does not exceed the amount of items B has asked so far. So subscription is the first step. So it's a single step. It just happens once in the whole lifetime of the data flow. So first we subscribe. And after we subscribe, we can ask for data anytime we want. It's an asynchronous message. So I can say, hey, send me 10, or send me 1,000, whatever you want. So we're going to ask for data. And then A can send events whenever it has events, right? In a way that it does not exceed the total demand. Okay? Cool, so that starts to give us that idea of back pressure and data flow, right? We have this communication between processes. And what is really, really cool about being demand-driven and about sending the demand when we ask for data is that we can effectively push the demand upstream. So what I mean by that is that imagine that now we have that pipeline, right? We have a bunch of processes that want to send data. So we have this process A that wants to send data to B, that's going to send data to C. Because of the demand-driven approach, we cannot start sending data. C is going to first ask B for data, and then B is going to ask A for data. And what this means is that you have the end of your code, okay, that is going to dictate how many events should flow upstream, and that is going to get up to the boundary of your system, up to the producer, and the producer can act on it. So for example, imagine that you want to do a data processing system that wants to get data from RabbitMQ, process it somehow, and put it somewhere else. With this system, you are sure that whatever is taking data from RabbitMQ is not going to flood your system, right? It's going to take only the amount of data it can process. And if any of those steps, right, throughout the whole pipeline, if any of them, because if you have a pipeline of data, one thing is sure, one of those processes, or many of the processes throughout your application lifecycle, they are going to be a bottleneck at some point. And you don't want them to get flooded with data, right? So that's why this communication here, it's really, really important. So we have C asking B for data, asking A for data, and then after we have the whole demand, A can send data in a way that does not exceed the demand, and then it gets to B. B does whatever it wants with the data and sends it to C. So we have this demand-driven flow. So at the end of the day, what is this demand-driven thing? It's just a message contract. It's just a way that processes talk to each other. And it's really nice because, as we saw, it pushes the back pressure to the boundary of our system, right? We no longer need to guess wherever we're getting data from, right? We'll be able to signal that and say, look, this is how much data I can consume right now. And the GenStage is just one implementation of this message contract. Anything can implement this message contract, really. And we got a lot of inspiration by the Akka streams and the reactive events that is happening there in the Java community and this whole idea of back pressure, okay? So this is nice. This solves one part of the problem, which is doing the data transformation, like that parallel pipeline, okay, in a way that it has back pressure. But we still need to solve this one, right? We still need to solve the GenRouter, okay? And the way we are trying to solve this right now is with the GenRouter. So the idea with here with the router, the issue, to recap, was we have this process, we want to get the data here, but it's always going to pass through the router, and that's going to be slow. So the idea with the GenRouter is that, remember I said the consumer needs to subscribe to the producer, and the reason why subscription is important is because what we can do now is that the consumer can subscribe to the GenRouter, An engine broker, its responsibility is only to broker connections between producers and consumers. So the consumer is going to say, hey, I want to subscribe. And when you subscribe to the engine broker, the engine broker will be like, hey, hold on tight, right? I got a subscription, but there is nothing yet. And then when the engine brokers, when eventually someone subscribes the engine broker to the producer, the engine broker's like, hey, you two should be friends, right? They have like producer A, and we have the one consumer. So you should talk to each other, and then the consumer is going to start to ask data directly to A without passing through the broker. And then eventually, if you go and subscribe the broker to another producer, the producer, hey, I have a new, the broker says, I have a new producer here, and I have a consumer there. You should definitely talk to each other. And then the consumer is going to start asking for data. And then if you add a new consumer, subscribe it to the broker is going to, look, I have two producers here. You should definitely ask them for data. Okay, and that's how the broker is going to get all those processes to know about each other, and the data can now flow directly between them without passing through the broker. And what is really interesting about the broker is that if we look a single producer to multiple consumers relationship, so for example, let's forget about everything else. So we have A here, right, that is a producer that is supposed to receive demand from 1 and 3 and send the data to 1 and 3. There are multiple ways where this producer can send data to 1 and 3, right? And that's something we put into the broker, which is the different strategies. So imagine that we have the producer here, and we have multiple consumers. We can use the broadcast strategy. That's the one that ships with GenEvent. So every time there is an event to the producer, like 1, it's going to send that event to all the consumers. Every time there is another event, it's going to send to all consumers, and so on, and so on, and so on. But that's just one strategy. We can have another strategy, which is, for example, the demand size. The producer is going to send data to the consumer that has the biggest demand, because you're assuming that the consumer with the biggest demand is the one that can take more work. Okay, so that's one way we could do it, right? So now, for example, there is one, and it's going to send to the first process, and then it's sending the data, and then at some point, you're going to have different demands, and it's always going to send the event to the one with the biggest demand. So that's nice, and that solves the problem that we have with the GenRouter, right, where all the data is going through one place. So we get the multiple strategies, and we can now effectively route events, right, but without going through that main router abstraction that would be a bottleneck. So if we look at the GenStage and GenBroker, together they solve the issue, right, from GenRouter. And we know that stages are separate processes, right? They're all processes in a pipeline, or in this case, when we're talking about the broker, they're all a bunch of different consumer processes. And we know that it provides back pressure. And we also support multiple broker strategies, okay? So this is a recap, right, of what we got right now. So we had we were talking about collections, then we talked about laziness, and then we say, look, we want to exploit parallelism, and then we tried to solve it with the GenRouter. And then stages, and that didn't work, so we added stages and brokers. And in stages, they only worry about transformation while provide back pressure. And we have the broker strategies, which is first, that allow us to send data around, right, using different mechanisms. So here's an example, okay, of how I kind of hinted at this. So we can have something that is taking data from RabbitMQ or any other system, really. And you want those events to be filtered because you don't want to process all of them. And then you want to send those events to something that is a dynamic supervisor. And what a dynamic supervisor is going to do is that every time a new event arrives to the supervisor, it's going to start a new child to handle that event, right? So, but as I said, the way this works is that the RabbitMQ, we cannot only start sending events. So what is going to start is that the dynamic supervisor is first going to say, look, I can handle 1,000 children at the same time, which is really great. I have one child and can barely handle it. So the dynamic supervisor is going to say, look, I can handle 100 children at the same time. And then it's going to tell the filter that is going to tell RabbitMQ. And then RabbitMQ may get at most 1,000 events, send it downstream. And then the dynamic supervisor is going to start 1,000 children. And then as some children finish their job, it's going to say, look, I have 100 more spaces. So it sends this thing upstream, and then RabbitMQ get 100 more, and so on, right? So we have that conversation going, and we now have this dynamic supervisor that can spawn children dynamically with back pressure, right? Some other example is that, so here what we are doing is that for every event, we are starting a new child, but what if for every event, I have already a pool of processes. I have like 16 processes or 4 processes, and what if instead of starting a new child, I just want to send to those different processes every time the event comes? So we can do that. We have, again, RabbitMQ. We have a filter. And now with the help of GenRouter, the filter can send data to all those different processes using whatever strategy it wants. So it's another way we can express those data pipelines, right? And both of them is going to have back pressure. And one is using the DynamicSupervisor, the other is using the broker system. So if you go back to what we wanted to do, which was improving OTP, now we have those demand-driven dynamic supervisors, right, where children are spawned on demand and we have back pressure. And we can see how we can use GenRouter to effectively replace GenEvent, right, because it solves all the issues we have with GenEvent. It's going to leverage concurrency because we are brokering data between different processes, so they're all running concurrently. They're not going to have those awkward error semantics anymore. And yeah, it solves all the problems we have described in the past, and it supports multiple strategies too. Okay, so that all sounds very exciting, right? And there is still a lot of work to do, but every time I come here and I give this presentation, sometimes I'm afraid I found like my half-life tree. I'll be presenting this for 10 years, and we actually would never deliver anything. But on the other hand, every time we come and we work on prototypes, we build some code, it feels that we are making the proper steps and going to the direction we want to. So what is the path forward? So far, we have written a lot of science fiction, which is basically documentation without the supporting code. So we have documented the message protocol, and we have some prototypes of the message protocol working. We have like defined the callbacks we want you to implement if you're implementing in stage, but we haven't wired everything together. So we need to finish GenStage, we need to finish GenRouter, and we have implemented the DynamicSupervisor, so the DynamicSupervisor works, but we need to revisit it later after the stage and the broker are ready so we can add back pressure, right? And you can follow all of those discussions. Everything is happening publicly. There is a repository under Elixir-lane called GenRouter, and we're going to be working more actively on that for the next months, since we have done a great breakthrough between the events. So that's it. Finally, I want to thank my company, Plataformatec, that is investing on Elixir and on the community for almost 5 years at this point, and all this research and development work is literally my job. That's what I'm responsible to do. And I also want to thank the Elixir community, and especially the Elixir core team. We have been working on a lot of those things together and all different issues together, and it has been a great experience. So thank you.